Okay, hello students. Next program is program number 4 in part A. Right. Okay, this is the corresponding question. Is in this to add an array of 16-bit numbers, right? And you have to store that in 32-bit result in internal RAM. Right. Okay. So this is the corresponding code. Right. Okay. So area we have given the name as addition. Code we made it as read only. Entry section, and these are the array elements. Okay, so you can take any number of array elements and you can give any value for the array elements. Okay, so just you give randomly, you have to add all these array elements and you have to store. Right. Okay, we'll store it on register, then we'll move back to corresponding row location. Right. Okay, we'll see one by one. Okay, so for now we have taken elements as 1 2 3 A B C. Right. Okay, so we'll be adding all these elements now. Right. Okay, so number of elements is what? 1 2 3 4 5 6. Right. Okay, hence we have initialize counter with 6. Okay, because 6 times we have to run the loop to add 6 elements. Right. Okay, so we are adding initializing counter with 6. Right. Okay, so initial value are not as taken as 0. Right. Okay, so here memory allocation name we have given it as value 1. Right. Okay, so if you run the program, see here. Okay, so we'll run step by step. First step is what? We are moving 6 to register R5. Here 6 value represent what? Number of elements in the given array. Right. Okay, you can take any elements in this array. Okay, the number may be varying. Okay, you can give 4 5 6. You can take any number of array elements. That count should be given to R5. Okay, which acts as a counter. Right. Okay, so you can see here R5 is initialized with 6. Okay, next index R0, we are taking it as 0. Right, anyway R0 is 0. And every time you have to observe how the program counter value is updating. Means every time you run the instruction, okay, so it will update or increment by 4 because each instruction is of 4 bytes. Right, okay. So next the value memory location address will be stored in R1. Right, load R1 with corresponding value address. Okay, this is the memory allocation. We'll see. So R1 takes the value, this value. Okay, so we'll check this in memory window. So give the same value in memory window. Then check the corresponding addresses. Right. Okay, so you can see here. It will show what are the array elements you have used. Right. Okay, so this 111, right, 222, 3 A, B, right. Okay, C, right. This is array of 16-bit numbers. Okay, so the question is what? We have to add an array of 16-bit numbers. Okay, that's why we have taken it as 16-bit, and you have to store it in 32-bit. Okay, so while taking array values, you just 16-bit numbers. While storing, we'll take entire register which is of 32-bit. Right. Okay, so what is first value? First value given it as 111. Right. Okay, since memory it is a continuous memory allocation, here we can see these elements are stored continuously. Right. Okay, so after loading address, so next we have a loop. Right. Okay, so to add element by element and store the result in one corresponding register. Okay, so here we are loading R1, that is first value 1, to R3, and will increment R1 pointer by 2 bytes. Okay, so if you remember, if LDR previously there we are incrementing by 4 bytes. Why? Each instruction is of 4 bytes. Okay, that's why. Here load RH. Okay, LDRH means okay, load half byte. Okay, here just we are loading half word. Okay, half word means what? Here it is 16 bit. Okay, here one word is 32 bit. Right. Okay, so half word will take 62 bit. Okay, why? Because your input we are taking it as 16 bit. Okay, just increment by half a word. Okay, half a word means just increment by 16 bit. Okay, so that it will point to next value correctly, right? Okay, so here you can observe the content of register. First value is what? 111, that is moved to R3, right? Okay, so next corresponding R1. Okay, so here R1 is pointing to first value, right? After loading the first value to register R3, now it should point to second value, right? What is second value? 222, right? Okay, so here you can see, right? Okay, so it will R naught contains what? Corresponding first value, right? Okay, so next you have to add R0 and R3, right? Store it in R0. Okay, so what is the first value of R0? Just we have taken it as 0. Okay, so here R0, you have to remember register R5 is acting as a counter here. Okay, so it will have a count how many times the loop has to execute, and R0 contains the resultant value. Okay, so every time you fetch the new array element, just you add it and save it in register R0, right? Okay, so first value we know that we initialize to 0, 0 plus first element 111. Okay, the resultant again you have to store back in R0. Okay, so always see here R0 contains the resultant. Okay, so next decrement R5. Why? Because it acts as a counter, right? Okay, one element you fetched and added, so you have to decrement R5. Okay, so R5 means previously it is 6, decrement by 1, it will become 5. Okay, which means what? Remaining is 5 elements. Okay, 5 elements are left out to be added, right? Okay, so next you will compare. So whenever you do comparison, you have to check the 0 flag, right? Okay, so until you reach 0 means until you perform all array elements addition, okay, you will be in this loop, right? Okay, so anyway 5 is not a 0, so you will be in the same loop, right? Okay, so it will be in the same loop. Next what it will do? R1, right? Okay, so next it is pointing to second element, you can see here, right? That is 2e. Give the memory location, that is 222, means which is nothing but the second element of the array, right? Okay, so fetch that element, just add to your previous resultant value. Okay, so just fetch, right, and store it in R3, right? Okay, now R3 is what? 222. Okay, so you have to observe the difference. Okay, so after fetching value from what, where register R1 is pointing, and move the content to R3, right? Okay, R1 will increment by what? 16 bit. Okay, so previously it is what? 2e, right? Okay, so for 2e if you add 8, right? Okay, so the next memory location is what? 30. Okay, so 30 will point to the next corresponding element, right? That is 333. Okay, so automatically LDRH, what it will do? Fetch the value present in this location which is indicated by register R1, right? And you will move to register R3, and this is the value to be incremented, right? Okay, so here you are telling 2 bytes, nothing but 16 bit. Okay, so that's why you are using LDRH. LDRH means so load half a byte. Okay, load register half a byte. Okay, just LDR means you are loading full word, right? Okay, so half word, RH means half word, just LDR means full word. Okay, so if it is a word, you have to increment by 4. Okay, yeah, just it is half word, you have to increment by 2 bytes. Okay, so just to observe, next fetched element is what? 2, right? That is second element, right? Okay, so just you add to R0, right? Okay, and again save back in R0. Okay, so what you will get? 1 plus 2, you will get 3, right? Okay, so the resultant is in R0. Okay, so this is simple, right? So you decrement R5, right? So anyway 4 is not a 0, so again you will be in same loop. Okay, next fetch the next element. Next element is what? 3, right? Okay, just save it in R3. So observe the content of R3. So now it is changed, right? Okay, so now add R0 and R3. Okay, 3 plus 3 6. So R0 is updated, right? Okay, now decrement R5, right? Okay, it will become 3. 3 is not a 0, so again you will be in same loop, right? Okay, so next fetch the next element, that is nothing but what? A. Okay, so your next element is A, that will be stored in R3. Now add R0 and R3, means 6 plus A. So what you will get? So 1 1 1 1 1. Okay, so you have to add hexadecimal addition. Okay, so whatever the addition you are doing or manipulation, everything should be in hexadecimal. Okay, so resultant is in R0. Again decrement R5, you will get 2. So anyway 2 is not a 0. So go to next loop. Next loop. So fetch the next element, that is B. Save it in R3. See, now the content of R3 is B. Right. Now add R0 and R3. So update R0. Right. Okay. So next decrement R5. R5 is 1. So anyway 1 is not a 0. Just fetch the next element. Next element is what? C. Right. Right. Add these two. Resultant will be stored in R0. Okay. So this is the final resultant value. Okay. You remember, you are using register R0 to store the final resultant value. Okay, you can use any other register also. You can use R5, R6, R7, R8. It is left to you. Okay, just you should know what is which register holding which content. Okay, so in this program we are using R0 to hold the final resultant value, and R5 is acting as a counter, and R1 contains what? Your starting memory allocation of this array. Okay, so you can use any register to perform any action, but you should know which register is having which value. Okay, so that you should be familiar one. Okay, so final resultant is in R0, right? Okay, so now if you decrement R5, right? Okay, so R0 will be 0. You can see that R R0 will reach it, right? Right, 0, and 0 flag is set, right? Sir, record. Okay, you can see here 0 flag is set, right? Okay, so it will come out of this loop, right? Okay, so next what you have to do, you have to store the result in this result variable, right? Okay, so what is the memory location? You can see we are declaring other data section, right? This is code section and this is data section, right? Okay, we made it as read write. Read write means you can edit the value, right? Okay, so this memory address will be loaded to R4. Okay, so now what is content of R4? So this value. Okay, you can see here, every time you have to check with memory window, so then it will be easy to analyze, right? Okay, so its starting value is what? 0. Means result you have initialized with 0. You can see here you have initialized DCD. Okay, so 0 x 0 means initial value is 0. So next what you are doing, you are moving the R0 value to R4. Okay, we know that R0 contains what? Final resultant value, right? That will be moved to R4, right? Okay, R4 contains what? This memory location address, means the final resultant value will be returned to this memory address. Okay, so you can check this, right? Okay, you can see here the final resultant is written in this memory location. Okay, so this is the end of your program. Okay, so just what we did, so we have initialized some array elements, each of 16 bit. Okay, here I have taken 6 elements. You can take 7 elements, 8 elements. Okay, it is up to you, right? Okay, so number of elements is left to user, and you can give any value for each element. Okay, so depending on number of elements you initialize that counter, that is R5. So remaining is same, right? So here final resultant. Okay, so the location will be given by R4, right? That memory address, and the final resultant is returned to this memory location, right? Okay, just you trace this program, right? Once you run. Okay, so just I will end. Okay, thank you.